In today's lesson, we're going to get used to using our trig ratios. Now, one of the things we're going to do is build on our previous knowledge of labelling right-angled triangles with trig. So first of all, we've got these rules, and you can see them in blue on the screen. We've got sine theta equals opposite over hypotenuse. Now, this sine theta is something new to us, but we should remember what the opposite over the hypotenuse is. So let's just deal with that first of all as a concept. So first thing we've got is when we have a right-angled triangle, such as this one, and we've got an angle, we need to be able to identify the sides of this particular triangle. So remember, the hypotenuse as the starting point is the longest side. The opposite is the one opposite the angle, so that's this angle here we were talking about in the first place. So this is the opposite, and then we have the adjacent. So what we can do is start to put some of the values into these trig ratios. Now they look a little bit complex, so we can simplify them a little bit down into this format. And to start with, don't get too stressed or worried about the sine, cos and tans. We're going to be working on those a little bit later, but today is just about identifying the different aspects so we can start to use some of these ratios. So we've got our first example here in this triangle, and let's just go ahead and label the component parts of the triangle that we're able to identify. So first of all, we're talking about this angle here, so our opposite is on this side, our adjacent is the one next to, and our hypotenuse is the longest side of the triangle. So now that we know some of these things, we can start to actually use the numbers. So first of all, we're going to take the rules that we've got here, and just substitute some values in. So let's write sine theta equals O over H. Okay, so we can replace the O and the H with the values from the triangle. So the O value in this situation is 5, and the H value is 13. So we've covered off on our sine rule. Now let's have a look at the cos rule. So cos theta equals A over H. And our A value is 12, and our H value is 13. Now let's have a look at tan. Tan theta equals O over A. Our O value is 5, and our A value is 12. So one of the things that we're going to need to get used to is actually using these different ratios, and a simple way we can remember them is this little trick here called SOHCAHTOA. So if we think about what this means, we've got S for sine, O for opposite, H for hypotenuse, C for cosine, A for adjacent, and H for hypotenuse, and then we've got tan and opposite and adjacent. So that's going to help us go through. Let's just have a look at another slightly different example. So in this new example, we've got the angle here being B, and we're going to go ahead and label our triangle. So we've got our opposite, our adjacent, and our hypotenuse. Now this time we're only going to use the ratio that can relate to this triangle for our known values. So we don't know what A is. So if we come back to our little SOHCAHTOA formula here, if we don't know what A is, we're not able to use tan, and we're not able to use cos. So we need to use the sine rule. So let's write that out to start with. So sine, and in this case we have been using theta, but we've actually got the angle named here as B. So sine B equals opposite over hypotenuse. Now instead of writing O and H, we actually know what the value for O is, so we can pop that in. We can say that that one's 6 and that one's 15. At this stage we're not going to go ahead and solve this, but we're just going to get used to being able to use the ratios, and that's going to assist us in our trigonometry later on.